most beneficent. Let us begin our second session, and I call this session 2 or track 2 because mostly on Sundays we will be discussing pure mathematics. And our discussion will start from mathematical thinking. In other words, we call it mathematical logic, or some other notations we may call it discrete mathematics. So the first thing is that why we need mathematical thinking to begin our course of pure mathematics. Because in pure mathematics we are mainly dealing with theorems, propositions, lemmas, corollaries, and so many other things. And we need to understand what is the language of a theorem. That is the first thing. So the first thing is that in mathematics we are using some sort of symbolic language, and we should have an idea that what do we mean by that language. And secondly, regarding theorems or propositions, we are mainly interested in their proofs. So whether we are going to prove a theorem or disprove a theorem, so we should have an idea that what are the methods to prove those particular theorems or propositions or corollaries. So this is the main thing, or the main part of pure mathematics, whether it is real analysis, function analysis, topology, or linear algebra or group theory. We are always interested in the proofs of the theorems. So we'll learn the fundamentals, that how to prove a theorem, and those fundamentals will always start from mathematical logic. So the first idea would be that we are going to build a language so that we can understand the theorems and we can understand how to prove the theorems. Then we'll do some basics, like basic examples, like what are the different ways to prove theorems. In this course, these things will be fundamental, but in real analysis, the things would be advanced. In function analysis, the things would be advanced, but the basic idea would be same. Like you have a method to prove what we call direct method. So direct method will be applied in so many other areas as well to prove different results. Similarly, we can apply it in function analysis, group theory, and so many other courses. We have some other methods like proof by contradiction, proof by contrapositive, proof by cases, which we can mainly use in number theory. Like we have to prove a result in number theory, that result holds for all the integers. Then we will divide it into 2 to 3 cases, like positive integers or negative, 0, or we can divide it into even and odd integers. So basically we are going to learn how to build such a theory so that we can understand theorems and we can prove the theorems. But mainly this is not concerned with our course. We are preparing for this type of subject specialist exam or some other exams, and we will not be asked to prove theorems, but we'll be asked to understand the theorems, and we'll be asked some questions regarding theorems. So at least we will not do some proofs in depth, but we'll understand how to prove, because when you study other courses, this might be helpful to you. But at least we'll be able to understand the theorems, because understanding of the theorems is very much important whenever some questions are asked in exams. So let us begin with this, Dr. Muslim. And we are going to begin our discussion with very basic things that you might know. In today's course, maybe some of you might know 100% of the things that I am going to discuss. Some of you might know 80%, some of you might know 50% or 20% or even less than that. But it depends. But I have to discuss these all things in detail. We'll be beginning with sets, and everyone knows that what do we mean by a set. Set is basically a collection of things which are well defined and which are distinct. We are not going in depth that okay, what types of sets are there and what are not the sets. Like we are mainly discussing that a null set is whether a set or not. But these are some exceptions in mathematics that we have to follow. Since there are so many modern mathematicians who are not agree with the basics of mathematics, what we call the mathematical logic or the theory of infinite simals, there are so many mathematicians who do not agree. But this is the foundation on which our mathematics is built, so we have to understand that. If we are reaching at that particular level, that we are becoming a good mathematician of our times, then we can rebuild the theory and we can tell the people, okay, this theory is good and it is answering our lots of questions, but there are so many lapses in this. So this is the new theory which have been built by us. You may use this. This will be even more exact theory, but it depends upon how you study. But a person from Pakistan might not be able to do that thing because our understanding, our foundations are not that much good. So our discussion will start from sets, but as everyone knows that what a set is, then we are going to leave this discussion because a set is simply a collection of elements which are going to be distinct and well-defined elements. And one thing we should know that we always denote the sets with some sort of capital letters, and we have some renowned sets like set of real numbers, set of complex numbers, set of rational numbers, set of irrational numbers. Sometimes we are unable to list down all the elements in the set of real numbers. So we'll just show that, okay, this is a set which is simply the union of q and q prime. Now the question arises, what is q prime or what is q? So now we are unable to list down all the elements in q. So what we'll do, we'll just say that the elements which are like satisfying certain property are called rational numbers. So let me write that. How can we represent this set in some sort of symbolic notation? We say that x such that x satisfies certain property P. So we always denote such type of sets in which we are unable to list down all the elements in this form. X such that x satisfies certain property. In the case of rational numbers, we can say that x such that x. Now we are going to write that property. Okay, x can be written in the form of p by q, and I think this is correct thing.
Yes, sir.
Where p and q are integers, and the problem arises when q becomes 0. So we are going to remove this q, which is 0. So this set contains all the elements which can be written in the form of p by q, where p and q are integers. And why we are doing so? Because we are unable to write q in the element form. Okay, the set integers can be written, you know very well, integers can be written in this way: 0, plus minus 1, plus minus 2, and we know the pattern what happens. What is the cardinality of a set?
Element
Number of elements. How to denote?
N of A.
Cardinality of a set. Let's take the name of set to be A. It means the number of elements. It can be denoted by n of A, or O of A means order of A, or some people denote it with this symbol, number of elements in set A, or this symbol. But maybe we will be mainly discussing or using this symbol in our discussion. So this is just fundamentals. And next thing is that we know very well what do we mean by subset. So A is subset of B. Is this proper or improper subset?
Proper. This depends on the
Improper.
We don't know about N B.
No. What does this symbol represent?
Subset. Improper.
Subset. Proper or improper?
Improper.
It's
It's subset.
subset.
It's generalized subset. It can be proper, it can be improper. Like we say that x is less than or equal to 2, it means x can be equal to 2 or less than 2. We don't know exactly. So this is just a subset. What is the definition in some sort of symbolic way?
Every element of set A belongs to A. B.
Every element of set
is containing
A
in B.
also belongs to set B. So we can write that x belongs to B for all x in A. It means whatever element you are taking from A set will also be part of B set. So this thing is very much important. We'll be understanding and we'll be learning how to understand or how to read these symbols. because in mathematics basically these symbols are playing a crucial role. So if you don't understand this particular thing right now, we'll be discussing, these are called quantifiers, and we'll be doing these things. Okay, we can show some sort of embedding that set of natural numbers is a part of integers.
Yes.
It means that all the natural numbers are also integers.
Integers.
And we can also say that all the integers are rational numbers, all the rational numbers are real numbers,
Real numbers.
and all the real numbers are the
Complex.
part of
Complex
complex
numbers.
numbers.
Yes.
And even this goes further, what we call quaternions or something like that. But we are not concerned about that. And one thing else, if A is subset of B, it means that the order of A, so what is going to be the relationship here?
Number of elements.
Order of A means number of elements in set A, order of B means number of elements in set B.
Less than.
Less
than.
Less than or equal to the order of set B.
Sir, relation thaiga. Yeah, improper line is the proper line is the marking yes. Improper line the initial size the marking yes subject line.
Yes. This is generalized, like this can be for
Subset.
proper as well as
Subset.
improper. But you will specifically say this thing,
This is proper.
this is a proper subset. But improper subset can also be written in this way,
Same.
that A is equal to B.
Yes.
This is.
We say that A is improper subset of B means A is equal to B. But I don't think this particular concept of proper and improper exists. In our context in Pakistan it exists, like there are proper subset, improper, but I have not seen somewhere else. Maybe I'm wrong, but I don't know exactly. Okay, how we define the union of two sets? A union B. We know very well it's a set which contains all the elements from set A
B.
and from set B, but we are not allowed to repeat any element. And you know very well the order does not matter in a set. Like you write 1, 2, 3 or 2, 3, 1 doesn't matter. But in union you will write all the elements from set A and B. So X such that X belongs to A, X belongs to B. What should I write here?
And
If it is union, then I will write OR. Because this X can be part of A or part of B, or it can be part of both.
Yes, sir.
But in the case of intersection, we have to write that X such that X belongs to A, X belongs to B, but in intersection it is going to be AND. Because we are taking those elements which are common in A and B. So this is going to be the definition of intersection. Similarly, what operations do we have? We have difference as well, I think. We write it A difference B, or we can also write it A difference B. These two symbols are used for difference. Mostly in some advanced books you will see this. So how to define this? X such that X
belongs to A,
belongs to A
and X does not belong to B.
and X does not belong to set B. It means if we make the Venn diagram, this is set A, this is set B, we'll write those elements in A which are not part of B. It means these are the elements of A which are also in B. So I will not write this part. So this is going to be the answer for
A minus B.
A difference
A
B or A
difference B.
minus B. So these generalized definitions are very much important when we are going to prove that one set is equal to another set. Like in De Morgan's laws, we know that A union B whole complement is equal to something else. Now the question is how to prove this. So we will be using these generalized definitions to prove that particular statement. What do we mean by cross product of two sets? It is X such that
X equal to A comma B.
yes.
Order pair.
So in this set, the element X is of which form? It is the form of an ordered pair A comma B. So this is ordered pair A comma B, where this first element A
Belongs to A.
is from set A and this B is from set B. So I can write for all A in A and B in B. It means you will take all the A's from A set and all the B's from B set and you will write these ordered tables. This is the definition of Cartesian product of two sets. And we can also say that how many elements are there in the cross product of two sets?
N of A and N of B.
Yes. So it means take the number of elements in set A and take the number of elements in set B and just multiply them. For example, if you have a set A with elements 1, 2, 3 and set B with elements A, B, and you know very well the cross product becomes like 1A, 1B, you will write this 1A, 1B and 2A, 2B and so on. So how many elements? You will see that how many elements are there. 3 times 2, 6. So these are just some of the fundamentals which we will be using regarding sets. Now the next thing is that what do we mean by functions? But we know very well all the things about functions. So we are not going to discuss these other things because if we are starting our discussion, it will suck a lot of time. We know very well a function is a map from one set to another such that each element from the domain set is mapped on a unique element from the codomain set. But I will be discussing one thing, that when is a function well defined.
Yes.
That's going to be the important thing. So
We may define symmetric difference also.
yes, we may define. I think that's not used in theory a lot. So most of the people don't do that. Because I think there is a relationship that you can convert symmetric difference into union, intersection and difference. So a function is a map from a set A to set B such that two things are kept in mind. One thing is that a unique element, every element from set A, it means from set A you have to take every element, is mapped to a unique element in set B. So you can take lots of examples, like set A is 1, 2, 3, this is 2, 3, 5. So I call this a function because one thing is that every element of set A is mapped to something, whatever it is. It means nothing is left blank here. And second thing is that it is mapped to a unique element. If there is no arrow like this, then we say that this is not a function because 3 is not mapped to anything. And if the things are like this, then this 2 is mapped to two elements. One is 2, another is 5. So 2 is not mapped to a unique element. So it's not a function. So there are two words which are kept in mind. Each element from the domain set must be mapped to a unique element from codomain set. The first set is called domain and the second set is called codomain. And range is part of codomain. Now the thing is that whenever we define a function, we write like this. F is a function from set of real numbers to, let's say, set of real numbers. It means this function takes values from real numbers and gives us the elements which are also real numbers. This is one thing that we should always mention, that where does the function start and where does the function end. Second thing is that we should give a formula that how the elements from these two sets are related. So when you define a function, these two things are very much important. Where does the function start and end? And what is the formula that relates the elements from those two sets? So let's say the formula is f of x is equal to square root of x. This is the formula. This sometimes can be written in this way. We are taking an element x and it is mapped to square root of x.
Yes, sir.
You can see that there is a difference between this arrow and this arrow.
Yes.
This arrow shows that this is domain set and this is codomain, and this arrow shows the formula It means this thing and this thing are same. You write this thing or you write this thing, there is no any difference. So in some books we can see this notation. So this notation simply means this thing.
Yes, sir.
Like we write some sort of exponential equations in logarithmic form, and we say that exponential form and logarithmic form are equivalent. So these two statements are equivalent, just the notation is different. So the question is this function well defined?
Defined for only positive.
Yes. The one problem with the function is when you take some sort of negative real numbers and you put this one, then you will get something not real,
Other than real. Yes, sir.
other than real. So you have to redefine your limits.
Yes, sir. Limits.
Either you have to redefine your domain
Domain.
or you have to redefine your code name set. So one thing that you can do is you can replace this R with complex.
Number.
Because whenever something negative comes inside the square root, your output will be a complex number. So your function goes from real to
Complex.
complex.
Yes, sir.
Or you can redefine it in this sense. You will say that these are only positive reals to
Real.
positive reals. I think you can also include
Yes, sir.
zero in it, because the square root of 0 is 0.
Whole to real.
Yes. So you have to check that whether your function is well defined or not. But let me tell you one thing, that in most of the cases your domain does not change, because your domain is something that is fixed. Your domain is a set of real numbers here,
Yes, sir.
so you cannot change this sometimes.
Yes, sir.
This domain can be the vector space that is given to you. Now, a vector space that is given to you, how can you change that vector space? I am going to give you a space, then you have to work on this space,
Yes, sir.
then you have to redefine your codomain set so that your function is well defined. Or the function that you have defined so far is not something good, then you have to do some manipulations in this one. You have to do some manipulations here. And you can also manipulate your function so that it is well defined. Whenever we define some sort of inner products on vector spaces, we define norms on vector spaces, we always check that whether that norm or that inner product or that metric space or whatever it is well defined or not. If it is not well defined, then we cannot move ahead. So this is like all about how we say that a function is well defined, and we'll be using this discussion in so many other courses whenever we have functions. Functions can be from R to R or N to Rm, but the functions can be from vector spaces to vector spaces. The functions can be from vector spaces to the set of reals or complex numbers. We call them, in some sense, we call them operators, and in some sense we call them functionals, which we'll be studying in function analysis. But this is not this is just used in whenever we are discussing single variable calculus. Okay, so let's go ahead and come to the point that we want to discuss. The first thing in mathematics or in logic is what a mathematical statement is, or simply what a statement is. I call this a statement or a proposition. So a statement is some sort of sentence, whether it can be written in the form of descriptive language or in symbols, that is either true or false. There is no any other third possibility. Means simply a mathematical statement or mathematical proposition, or simply the statement is a descriptive sentence or simply a statement that can be classified within two categories, whether it is true or false, no in between. There is no any other third possibility. So a statement or a proposition is a sentence that is either true or false. So statement is a sentence that is either true or false. Any example?
It is day or night?
Yes, it's midday. It's true.
2 plus 2
It's
is
night. It's false. So it's a statement. So a statement is something that is either true or false. Is this a statement?
Yes, sir.
Yes.
Clear, sir.
2 plus 2 equals 5.
False.
Yes, sir. False.
It is false. But a statement is something which is either true
Either true
or false.
Also.
What is which is not a statement?
X plus 2 is equal to 5.
X plus 2 is equal to 5. Why?
Because we can't define any value for x. We haven't given any value.
So we can say something about that. Or not?
Greater than or equal to x plus 5 greater than or equal to 5.
You can say something
Both
about
not
that.
satisfied.
I may say 2 plus 2 equal to 4 and 5.
Yes. 2 plus 2 is equal to 4 and 5. So at the same time, we cannot decide that whether 2 plus 2 is 4 or 5. So it is either true or false. So we are unable to decide. There are lots of examples which are not statements. For example, I say you open the window. It's a sentence.
Yes, sir.
Open the window. How can you say that whether something is open the window is true or false? It's just an order.
Order.
It's just an order. So it cannot be quantified or classified between a statement, like whether it is true or false. In simple words, in mathematics we start with the statements, and statements is that we may consider them to be true or false. But we need some extra information that we are going to classify them as true or false. In some sense your question is right.
Yes, sir.
Saying x plus 2 is equal to 3.
Yes, sir.
It's an equation, but if we are given some information that okay, there exists an
Yes,
x
yes, sir.
which satisfies this condition, then we can say that okay, there exists some x.
It depends
If we are
on-
just saying x plus 2 is equal to 3,
Yes, sir.
it cannot be classified as a mathematical statement
Yes, sir.
because there are some problems with this. And we have to just put some additional information
Additional information.
to
Day
say
to day.
that whether it is a statement or not. Okay, there is one classical example. I write something in this box which is a statement, and you have to tell that whether it is true or false. So this statement is false. So what is written in inside this box, whether you classify it to be a statement or not, whether it is true or false.
So not it is not in the statement, sir.
Why?
Because there isn't any statement given. We can't decide that which statement is true or false.
I say you that inside the box, whatever is written is correct, is true. But the statement itself says that I am false. So this is a sort of contradiction. I say that whatever written inside this is going to be a true statement,
Yes, sir.
but the statement itself says that I am false. So what can we decide about this? So this is going to be a contradictory situation. So this is not a mathematical statement.
Statement, yes, sir.
So there are lots of examples when we come to discuss mathematical statements. So this is something that we should only understand that okay, whether something is true or false is called mathematical statement. But the real story begins from here. What is the negation of a statement? Denoted with this symbol.
Yes, sir.
This is not 7, this is a symbol like this. So what is the negation of a statement?
Negation of true is false and negation of false is true.
What is negation? You're right. What is negation? You can relate this particular thing with English language as well. Like if you are given a sentence,
Affirmative.
affirmative,
Interpreted.
And we are
Negative.
making it negative.
you are making it negative.
Yes, sir.
So
Negative.
this is the negation.
So this is negation.
Negation. Not.
This is negation.
Yes, sir.
I say I'm a doctor. This is a statement, for example.
I am not a doctor.
I'm not a doctor. I'm a
Negation.
teacher.
I'm not a teacher.
I'm not a
I'm
teacher.
not a teacher.
Okay, but you can always decide that whether your statement is true or false,
True or false.
and whether your negation is true or false.
True or false.
It should be true. I say I am a doctor. It's a false statement. I say I am not a doctor. It's a true statement. So one thing out of these two will be either true or false. Any one thing. Both cannot be true at the same time, and both cannot be false at the same time. So the next thing to study logic is to understand how to create some sort of tables. In logic we call them truth tables. Tables that show that whether your statements are true or your statements are false. This is going to be the very fundamental stage, and some of you, if you have not heard of this subject or you have not studied this, then this is a great opportunity to learn, but the course is very fundamental. Okay, so we discussed what do we mean by negation. So if you compare this with English language, it's just the negative of a sentence. So you are given an affirmative sentence and you are going to make the sentence to be negative. So the next thing that we will be doing for the rest of this subject is what we call truth tables. And it's some sort of table which is arranged in some columns. The columns might be 2 or more. And in the first column we are writing a statement that is given to us is statement A.
Yes, sir.
Now what are the possibilities of this statement? There are only two possibilities. Whether the statement is true or the statement is false. And we know very well that if the statement is either true or false, or we are not sure about that, that is not a statement.
Yes, sir.
So we cannot classify that particular thing in this table. So the possibilities for A are only true and false. Then you have to make the other columns of this table, what we call the truth table, by considering the first column or the first two columns that are given to you. The very basic thing is that if a statement is true, then its negation is false. If a statement is true, so let me give you an example of a statement which is true. I am a teacher, which is true. So I am going to negate this statement, I am not a teacher. Obviously that statement would be false. So if you are given a statement A, you have to decide that what are the results for the negation of A. So whenever any statement is given to you which is true, obviously the negation of that statement is written as this symbol is always false. If a statement is true, its negation is false. If a statement is false, its negation is going to be true. But the condition is that it must be a statement. Let me take any false statement. It's night right now, which is false. What is the negation of this statement?
It's not nice.
It's not night.
It's not right.
Like I take any other false statement, I am a doctor. What is the negation? I am a doctor is false. I am not a doctor is true. So this is going to be the first table that we have made so far, and we call this truth table, and we will be making such tables for the rest 8 to 10 topics that are going to be discussed in this thing. So a statement is true, its negation is false. A statement is false, its negation is true. So this is the first truth table that we should understand, and we should know about the negation of a statement. How about this? Negation of A, and you take double negation. It means you negate the sentence and you then negate the sentence again. So what are the possibilities for statement A? It can be true or it can be false. What are the possibilities for the negation?
False.
You will not write the possibilities for negation, but you will deduce this from this information.
Yes, sir.
Okay.
Yes, sir.
When I say possibilities, it means you have to randomly write the things by yourself. Okay, the possibilities are true and false. But when I say that you have to deduce this information, it means you have to decide this by keeping in view this particular statement. If this is true, this is going to be
False.
If this is false, this is going to be
True.
What should be the result here?
True.
Because you have negation of A, you are going to negate it again.
Again.
So false becomes true and true becomes false. Can you see relationship between these two things?
Original statement.
Yes.
Yes, sir.
So if you negate the sentence two times,
Two time.
it becomes the original
Statement
sentence.
itself.
And there are so many examples for this, like you have a matrix, you transpose it and you transpose it again, you get matrix A.
Matrix.
There are lots of examples. And you might think of other examples as well. Okay, so this is like we have a statement and we are going to negate it. It means we are concerned about a single statement. What if we are given two statements? A statement, let's say statement A and a statement B. How can we connect those statements? What are different connectives that we have?
And
So in English language, you use basically these two words
yes, sir.
to connect the sentences. One is and another is or. Similarly, you can connect some mathematical statements in this way as well. These things are called logical connectives. So and is written in this way and or is written in this way. And again the question is that if you have a statement A and a statement B, what should be the truth table for A and B?
Yes, sir.
I am going to make it a bit concise, otherwise we will be discussing lots of examples. But this is something which is very much fundamental and you have to understand this. I am given a statement A, I am given a statement B, I have to decide the values for A and B. Now, as I told you earlier, the something that is given to me is decided by us.
Yes.
It means we'll write different possibilities.
Yes, sir.
What are different possibilities for A and B?
True, false.
Either both can be true,
True.
or this is true, this is false, this is false and this is true, and
This is false.
this is false and this is also false.
Yes.
So keeping in view this information, what can we decide about A and B?
Yes, sir.
If A and statement B both are true,
Both are true.
it means A and B is also
True.
an example. You give me statement A and statement B. In English, it doesn't matter, it should be in mathematics. And both are correct, then we have to decide whether whole statement is correct or not.
I am a teacher, I am a male.
I am a male and I am a teacher. So, I am a male is correct and I am a teacher is correct. So, the whole statement A and B is going to be
Yes,
correct. So, whenever you connect two sentences by and, you have to look for both sentences. If both are true, your result is going to be true. Okay. And what about rest of the possibilities?
False.
So, whenever the connective is and,
And
both statements are true,
true.
your conclusion is
It
true.
will be true. Yes.
Otherwise,
All will be false.
it is false in all the remaining
All the
cases.
remaining cases.
It is false in all the remaining cases. And why?
What about last one? I am not a teacher, I am not a male. Okay, it is also false.
It's wrong.
Alright.
Okay, I am a male and I am a teacher is correct. Okay, because both are true, so the whole statement is true. I am saying I am a male. I'm true up to here, and I am a doctor. When you just evaluate my whole sentence, it's false. It's false. I am a male Okay, you agree. And I'm going to give you some additional information. You will believe me if my whole information is correct. You will say me that, okay, you are false if any part of my statement is going to be false. I am a male, you are agree with this. And I am a doctor. You say, no, this is wrong. So my whole statement is going to be wrong. If my both A and B are false, so obviously whole statement is going to be false. So you have to just keep in mind this particular thing, because these 8 to 10 truth tables we will be using at the end to prove some other results that might be helpful for your exam point of view. But I think to understand this particular thing is not a big deal for any one of you. Okay, what is the other connected? One is and, another is or. So again, we are interested in the truth table of A or B. So what are the possibilities? Both are true, true, false, false, true, and false, false. So what should be done here? There is no any discussion on the first part,
Yes, sir. Always true.
because when both are true, it's going to be true, and there is no any discussion on the
Yes, sir.
last part.
False.
If both are false, it's going to be false. The main problem is the statements between these two, or the conditions or the cases between these two, which
Yes,
is
sir.
A is true, B is false, A is false, B is true. In this case, the result is false, false. What should be here?
Either of two must be. If either of two is true, then the statement result will be true.
The result will be true.
Yes, sir.
It means if your connective is or,
Or
then any one of the statements is true, then the result will be true. Anyone is true is mandatory. If both are false, it is false. If both are true, it is true. If any one of them is true, the result is true. But it is opposite to this case. Why? Because here our connective is and requires both to be true.
Both to be true.
And this or requires any one of them. Any one of them or at least one of them to be true.
One should be true.
One should be true. Either both true
Either.
or any one should be true, then the result will be true. Any example for this?
So I am a student and I am a male. I am a male, but I am not a doctor.
You have to use this or. I am a male, so I am saying I am a male,
Or
I am a doctor. So this is false. This is true. But you will believe that whatever I am saying, when you see or, you will believe that my information
is true.
is at least on one side true.
One side is true, yes.
Either this side is true
Yes, sir.
or this side is true or both are true. You will believe them whenever I say or. The other example could be, I am going to attend the wedding ceremony, or my brother will be going to attend. It means that if I am going, okay, it's true, or my brother is going, it's also true, and it might be the possibility that we both are going. But if we both are not going to the wedding ceremony,
This is the false.
this is something false. It means whenever in English language or mathematics you get this or, you have to believe that any one of these things should be true. And in mathematics we can say that for all x to be part of real numbers, it means you take any real number, then either that real number is greater than 1. Do you believe this? Am I right or not? You take any real number, either that real number will be greater than 1,
Yes, sir.
it might be possible.
Yes, sir.
If it is not this,
Yes,
then it will be less than or equal to this. It is a possibility.
Yes,
It is a
yes.
possibility. It's true.
True.
Why it is true? Are these both true? Is it possible that both of them should be true?
No.
It's not possible.
No.
It's not possible. But any one of them must be
Must
true.
be true.
Because you take any real number, we'll apply this property in the construction of real numbers, what we call Dedekind cuts. This is related to this, somehow related, I think. So you got truth table for A and B, you got truth table for A,